Hi, good evening, students. Welcome to the chemistry class. Everybody's there, right? So are you all excited for the new chemistry class today? So today's agenda is we'll be discussing three different concepts. Okay. So that is chemical bonding and molecular structure. Okay. And the next one is gaseous state, means properties of gas, real gas, ideal gas, kinetic gas equation, and also thermodynamics, means heat changes. Okay, I hope everyone is excited. Okay, so let us start the first question, right? So are you able to see the screen properly? If there is any issue, please let us know, and you can ask whatever the small doubt, no, please ask in the chat box. I'll be going through your doubts also. Okay, so we'll immediately answer this doubts. In the previous class, what we did is basic concepts of chemistry and also atomic structure. Okay, is that clear? Sure. First question. Okay, see this question. This question is asking about formal charge. Okay, do you know what is formal charge? How do we define formal charge? Okay, so I'll be discussing that first. Formal charge means, so this is the charge remains on the element, okay, after sharing electrons with another element. Understood, right? Because in every molecule or ion, element can carry charge. So that can be easily calculated, because suppose oxygen valency is how much? Valency I'm talking about, okay? Valency is 2. This is valency. Valence electrons are 6. Correct? Now, how many electrons it is getting in the compound, that will decide the charge. Suppose if it gets 7 electrons instead of 6, now the charge will be minus. But if it gets only 5 electrons, charge will be plus. So based on this valence electrons, will calculate formal charge. Okay, so I'll give you the formula, very simple. V minus L minus 1 by 2 S. Okay, I'll be discussing each and every term. Okay, so please note it down. V means what? Valence electrons. Okay, and next, no, what is this? L means? L means non-bonding electrons. How many non-bonding electrons are present on that particular element? What is S means now? S means how many electrons are shared? Very easy. Understood, right? Formal charge is the charge on that element in a given compound when it may lose electrons or it may gain electrons. Okay, so based on valence electrons will decide the charge. Now look at this ion, PO4 minus 3. First let us write, no, what is phosphorus valency? Can you tell me what is phosphorus valency? Be quick, no, I'm expecting answer from everybody. My voice is clear, right? Yes. Okay, I'm getting the answers. Very nice. Okay, so phosphorus valence is 5. So let us make 5 bonds for phosphorus with oxygen. Okay, right, I'm making 5 bonds. Look at this, no? But how many oxygens are there? Look at the structure. There are only 4, right? Exactly. There are only 4 are there. So I have written 4, but phosphorus valence is 5. So what I'll do, one extra bond I'll make. See, this is the way to write structure of molecules. First, decide central atom. How do we decide central atom? Sir, we have two atoms, phosphorus, oxygen. Why you have not written phosphorus, oxygen in the central? Because very simple trick. Very simple trick. The element with maximum valency is central atom. Phosphorus valency is 5. Okay. Oxygen valency is 2. So I placed phosphorus in the center. Now I distributed oxygens so that phosphorus must get 5 bonds. Yes, less electronegative you can say, but the most proper way is maximum valency. The element with maximum valency is central atom. Okay, Vishal? Okay, right. Now, but there are charges too, right? PO4 3 minus. So I'll keep the charges. Listen now carefully. So -1, -1, -1. The 3 charges. So I've written 3 minus. Sir, why don't you put oxygen charge here? It is again very simple trick. See, look at oxygen. Look at oxygen here. There are 2 bonds, right? We know valence is 2. Valence is satisfied. So why it will show charge? It will not show any charge, right? So look at phosphorus. Phosphorus will show any charge? No, because its valence is 5. All 5 bonds are formed. Is that clear? So if all bonds, all valencies are satisfied, there will be no charge. As simple as that. Okay, fine. Now, what they're asking is formal charge on each oxygen atom. What is this question then? There are 4 oxygens. So what will be the formal charge on each oxygen? Look at this, no? -1 charge on 3 oxygens. There is 0 charge on this particular oxygen. The top oxygen charge is 0. It is very clear because all the valences are satisfied. Now what I'll do is total charge I'll take, because all are oxygens, right? Total charge by number of oxygens, number of atoms which are sharing. Okay, so that will give average charge. We need average charge because on each and every oxygen they are asking, but there are 4 oxygens. So that must be average charge. Okay, fine. So how do we calculate this average charge? So it is very simple. Now we have the formula, correct? So what I'll do is I'll take the average charge. Total charge is how much? -1, -1, -1, -3 by number of atoms. How many atoms are sharing? 4 atoms, right? -3 by 4 or -0.75. Yes. So look at the options. No? Look at the options. -0.75 is present in almost 3 options. Okay. So this cannot be the answer. We eliminated one option because -3 cannot be the answer. -3 by 4. That is average charge. Now, one more thing they are asking, PO bond order. What is bond order? Do you know what is bond order? Let us discuss bond order also. Bond order means it is simple. Average number of bonds. Average number of bonds between the elements. Okay. Average number of bonds between the elements. Now look at this. No, how many average number of bonds are there? How do you calculate this? No? Can we do it now? How many average bonds are there? Total bonds. Tell me. Say, look at the average charge formula. How we did this? Look at this formula. From this, we will get average bond order also. It is very simple. Because all are oxygens, correct? All are oxygens. Exactly. All are oxygens. So how many bonds are there? Each single line is there. No, chemistry. Chemistry line has a meaning. Line is bond between elements if you write it. Right? So tell me now. How many bonds are there total? Look at this. There are 5 bonds. 5 bonds. How many oxygens are sharing now? How many oxygens are sharing? Fast. Everybody should answer quickly because very simple question, right? You should understand in depth. No, 5 bonds shared by 4 oxygens. So how much it is? Average number of bonds. No, so bond order I'm writing BO. See how I calculate BO now. BO is equal to total number of bonds by total number of atoms. 5 by 4, 1.25. This is plus. Obviously, bond order cannot be negative, no? So, our correct option should be what? Option A. Understood, everybody? So, we calculated average charge and also average number of bonds. Is that clear? So, two concepts should be very clear from this question. How do we calculate formal charge? Okay. And also, how do we find out bond order? The two concepts with one single question. Now, look at this question. No? Consider molecules CH4, NH3, H2O. Which of the following is false? Look at this statement clearly. No, they're asking false statement, not correct one. But how do we compare this bond angles? They have given no options. Bond angle of H2O is smaller, or NH3 is smaller, or CH4 is smaller. How do we calculate this? I'll tell you one very simple trick. Okay. So if you listen to this trick, no, you will never forget in your life. Okay. Not only for any competitive exams, in whole life also, you will never forget this. Okay. But for that, some basics, no, you should know. What is that? No. Suppose CH4. I need to know the shape of this molecule. Okay. So for that, we know central atom finding. Yes. What is central atom? Carbon is central atom. Now, what is the valency of carbon? Carbon valency is 4, right? Carbon, organic chemistry, total. All carbon compounds we study in organic chemistry separately. Every time we write carbon infinite times, no, you might have written in your notebooks, right? What is the valence of carbon? That's a 4, right? So listen, guys. Now I'm writing 4 electrons here. Like this cross marks, no, they're electrons. Okay, fine. Now what I do is hydrogen valency is what? Hydrogen valency? Hydrogen valency means how many bonds hydrogen can form? Only one bond. Yes, one bond. It uses one electron. One bond. It uses another electron. One more bond. One more bond. Is that it? Done. All electrons are over for carbon because there are enough hydrogens. Now let us count this number. What is this number, sir? This, no, it is called now bond pairs. This is one pair. Okay. This is another pair. Second one. This is third one. This is fourth one. So this is called steric number is equal to number of bond pairs plus number of lone pairs. Okay, so if you know the steric number, we can predict the geometry, we can predict the shape of a molecule. Okay, fine. So now what is steric number here? Steric number is equal to 4. 4 means hybridization we can easily find. What is hybridization? S. Without S, there is no hybridization. Okay, the first should be S. Now S means there is 1. Total we need 4, right? 4 steric number. So P and 3. This is basically sp3 hybridization. Okay. So what I'll do is, erase this I can write very simple way, sp3, s1 3p, total 4, right? sp3. So carbon hybridization is sp3. If it is sp3, then tetrahedral shape. What is a bond angle? bond angle is 109.5 degree. Similar way, what you can do is you do it for NH3 and you also do it for H2. So what I'll do, I'll give nitrogen central atom, oxygen central atom. Now, can you please tell me, first find out what is hybridization in NH3, what is hybridization in H2? Very fast. Use the same method. Nitrogen valence is how much? 1, 2, 3, 4, 5. Valence electrons. Oxygen central atom 1, 2, 3, 4, 5, 6. Write these electrons, and we know already hydrogen valency. So can you please do it quickly? Fast. So NH3 and H2. So what you got? sp3, sp3, both are sp3. Very good, well done. Okay, so this must be sp3. So this is sp3 because see this hydrogen, 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 and this one pair hydrogen, hydrogen. You will get these pairs. They are called non-bonding pairs or lone pairs. sp3 plus one lone pair and sp3 plus two lone pairs. Now CH4 sp3 hybridization, but zero lone pairs. There are no non-bonding pairs. All electrons are involved in bonding. So now very, very important concept. If hybridization is same, bond angle, I'll write this. BA means actually bond angle. Fine, we'll use total. Bond angle inversely related to number of lone pairs. Means as the lone pairs increases and hybridization remains same. Look at this hybridization. What is this? sp3. Yes, sp3, sp3. Hybridization is same, but zero lone pairs, one lone pair, two lone pairs. As lone pairs increases, bond angle will decrease. Now tell me, which option is correct? Look at the options. Bond angle should be least in H2O, right? So which is false statement? Which is false statement? D. Very nice. Okay. So D, it is saying H2O is larger. No, never true, right? H2O is less. So bond angles order, if you see bond angles order, so which is highest now? CH4 is highest. Yes, no doubt. NH3 because one lone pair, H2O two lone pairs. As lone pairs increases, bond angle decreases. As simple as that. Okay. Got it? Shall we move on to the next question then? You understood the theory, right? Focus on the theory. Hybridization must be same. That is our condition. If hybridization is same, the rest, it is bond angle is inversely related to number of lone pairs. Fine. Next question. Let us take this beautiful question now. Correct order of carbon-oxygen bond length. See, we are focusing on electrons and we are focusing on bond parameters, bond angles, bond lengths, bond order. Okay. So look at this question. They are asking bond length. What you should know is I'm writing relation between these bond parameters. We have three parameters. One is bond order. What is bond order? Just now we discussed, number of bonds. Okay. Next, bond length. Okay. Next one is bond strength. So these three are bond parameters. They're interrelated. They're interrelated. So bond order is directly proportional to bond strength. That means what? More is the number of bonds, more are attractions. No? Stronger is the bond. Exactly true. But inversely related to bond length. That means more attractions, what will happen? Atoms will come very close. Yes or no? Atoms will come very close. So bond length, distance between them is less. Now, which is correct? So let us find first, no, what is a bond order between this carbon and oxygen? Okay, carbon, oxygen. What is a bond order? So let us write, what is a bond order? BO I'm writing. What is bond order? How many bonds are there? 3. Very easy, sir. There are 3 bonds, right? Everybody can see this, right? Yes. Next. CO2. CO2. Carbon is a central atom. Just now we discussed in the first question, how do we write structures? Choose central atom. Based on the valencies, you distribute other atoms. So what is the bond order? How many bonds are between? Sir, there are 4 bonds I can see. Yes. But 4 by 2, no? I said, right, just now, the first question says no bond order, because 4 bonds are there, fine, but 2 atoms are sharing this, right? So 4 by 2 is 2. Is that clear? Okay, next, CO3 minus 2. Okay, CO3 minus 2. Carbon valency must be 4, maximum 4, right? CO3 minus 2, minus, and double bond 1. Fine. What is the bond order now? Bond order is equal to how many bonds are there total? Sir, we can see 4 bonds. Yes, there are 4 bonds. How many atoms are sharing? Very simple trick we discussed in the first question, right? 4 by 3. Very good. 4 by 3. That means 1.33. Now, question is asking bond length. Now tell me the answer. Everybody knows this answer right now. Bond length, bond order, we know it is inversely related to bond length. If bond order is more, least bond length. Where is least bond length? So this is CO. Yes, CO, A, C, D options. B is not correct. Okay, B ignored because CO3 minus 2. Okay. So this is given least. That should not be the case, right? CO should be least bond length because more is a bond order. So that means we are highlighting these two. These 2 bound parameters. Okay. Now, correct option. CO3 minus 2 have least bond order, maximum bond length. Option C. Exactly. Okay. Fine, fine. I got the answers from many students. Right. Very good. We're done with bond parameters question, right? Shall we move on to the next question? Yes. Now, one more interesting question here. Okay. Now this question says, in which of the following molecules all the bonds are not equal? What is this question? How we know that bonds are not equal or equal? It is very simple. We should know the geometry. Okay. We should know the geometry. If I tell you a molecule is linear, suppose, no, if I tell you a molecule, what I'll take is AB2. This molecule, let us say linear. So there are 2 lines you can see, right? Are they same or different? Are they same or different? Bond angle is 180 degree. Are they same or different? Bonds are equal. Yes, exactly. Equal. But see, if A, I placed a lone pair here, and this is B, this is B. Now what will happen? Are they same? They may not be same. Okay, they may not be same if there is a lone pair. If they may not be same if there is a lone pair. So just look at these molecules where we get lone pair. Just now we discussed the trick also, right? To find out hybridization. So first one I'll do, the rest you can do easily. NF3, obviously, which one is central atom? Nitrogen, because nitrogen valence electrons are 5, right? Yes, valence is more for nitrogen, so I'll choose nitrogen here. So I'll write 5 electrons, 1, 2, 3, 4, 5. Out of 5 electrons, how many can form bond here? Sir, only 3 fluorines are there, so 3 can form. Yes, NF3 plus 1 lone pair. Okay, fine. NF3 lone pair. Look at the shape. Now, if the shape is different, bond lengths can be different. Bond angles can be different. Sir, there is a lone pair. Will they different? Are they different completely? It may be, I said, no, it may be different. It may not be different. But in this case, no, what is the shape? Just depends on the shape, no? sp3 plus 1 lone pair. It is a pyramid. In pyramid, no, you might have studied in history, no? In Egypt country, there are pyramids, big pyramids. So look at the bonds, no? They are definitely same, right? They're not different. NF bonds are same length. Exactly, right? Pyramid. So this is not correct. ClF3, Cl is central atom. So quickly write how many electrons are there? Cl, 7 electrons. It is 7th group, right? 1, 2, 3, 4, 5, 6, 7. And look at this. Fluorine. Yes, 1, 2. Okay. So look at the count now. What is the steric number here? Tell me, what is the steric number? 5. Steric number is 5. No, 1, 2, 3. 3 bond pairs. Yes, plus 2 lone pairs. So 5. If you include all this, what is the number here? This is 5. So if it is 5, no, tell me, what is the hybridization? What exactly the hybridization? sp3, S should be there. Yes, sir. sp. Now, can I write p4? No, I can't write p4, right? p4 is wrong. Maximum p orbitals are 3. Next, D. Exactly, sp3d. Now look at this structure of ClF3. ClF3 should be like this. sp3d plus, no, 2 lone pairs. But where I should place 2 lone pairs? Fluorine. Yes, fluorine. Okay. This fluorine. And lone pairs must be like this. We know it as T shape. We must place, no, on this position only to avoid maximum repulsions. To avoid maximum repulsions, most stable position is this. Yes, T shape. Now this is T shape molecule, so everybody knows. Now look at the bond length. No, this length is definitely different from this length. This is actually called, no, this is called equatorial. This is called axial. FA. I'm writing this. No? FA. This is FA. FA means axial. FE means equatorial fluorine. So in general, I'm telling you the trick, no? F axial bond lengths, no, more than equatorial bond lengths. Because if you see axial, what is the bond angle? It is just 90 degree. But equatorial, it is 180 degree, 120 degree, sorry. Equatorial. It's a triangle. Okay. So 120 degree. So axial bond lengths are always, no, more than equatorial because their bond angles are different. Repulsions are different. If they're 90 degree, that means repulsions are more. Atoms are very far. Bend's rule. Very good. Okay. This is actually Bend's rule. So bond length we can compare. So this is one of the most important geometry is this TBP, trigonal bipyramidal. Whenever this case comes, no, axial is more than equatorial. So ClF3, it doesn't have equal bond lengths. So in any question, no, if they're asking unequal bond lengths, the first thing should come to your mind is this geometry, this shape. No? What is the shape? sp3d hybridization and trigonal bipyramidal shape. Okay. Next question. So which of the following pair of compounds is isoelectronic and isostructural? Can we do it quickly now? Isoelectronic means what? Same number of electrons. Okay, I think you can do it later because we'll provide notes also, because very similar question. Same number of electrons, you count electrons. Okay, and isostructural. Structural means same shape. How do we find shape? Same hybridization should be there and same lone pairs. You can solve it, right? Okay, please solve it later. The same concepts you can apply. And look at this question. Very, very important model it is. Which of the following has p pi d pi bonding? P pi d pi. You can clearly see each and every molecule has pi bond. Yes or no? Oxygens are there, right? Oxygens are there. There should be a pi bond. Fine. But what is p pi d pi bond? It is pi bond between p orbital and d orbital. So we can easily eliminate the options here. Easily, very easy way. Nitrogen, is there any d orbital in the first case? Nitrogen, oxygen, is there any chance? No, never possible, right? Nitrogen cannot have d orbitals. Oxygen cannot have d orbitals. Second period elements, no, they never have d orbitals. So you can eliminate this. This is not correct. This is not correct. Boron, carbon, nitrogen, oxygen, they are all belong to which period they are? They belong to second period elements. In second period elements, in periodic table, if you see, you will never have no d orbital. Yes or no? Yes. But sulfur, yes, third period elements. So correct answer should be option B. Got it? Very simple way we can eliminate. Yes. I hope everybody got the clarity. Right. Next question. Now let us come back to this another important topic in chemical bonding. How do we find paramagnetic, diamagnetic? So most of the students have this confusion. What is that confusion? Sir, even number of electrons so that all can be paired. They are diamagnetic. But what exactly the meaning of paramagnetic? Suppose a substance is paramagnetic. What is the meaning of this? No? It is weakly attracted by magnet. Got it? But sir, how do we know whether these molecules are getting attracted to magnet? We can't check, no, with magnet. You can't put pen, you can't put the magnet on the laptop or mobile screen and check, right? That is not possible. We can't check, right? Exactly. So all electrons are, if all electrons are paired, that is diamagnetic. Diamagnetic. Okay. If at least one unpaired electron, no, paramagnetic. So count number of electrons, okay, and just check. Let us see. Just a second. I'll come back. Just see this, no, whether which one is dia and para. Should get more and more answers, no? Do it. Very easy. Where electrons are getting paired, that is diamagnetic. I'll tell you one more trick for this also, okay? Because we should use molecular orbital diagram for this. I'll be giving the trick. Okay. So yes, O2 is paramagnetic. Everybody should know this. Okay. I'll be giving one more trick. So look at this carefully now. Molecular orbital diagram we should know. The next question is also targeting this. So please listen carefully. Next questions, no, they may ask which is diamagnetic, paramagnetic again, but you should do it very carefully. Okay. Don't by heart this. I'll tell you. Dissociation energy also, I'll tell you. Okay. Don't worry, Arpit. I'll tell you. MOT. So molecular orbital theory we use for this. It is used, no, till 20 electrons. Means hydrogen, helium 2, lithium 2, beryllium 2, till any 2. Till that, no, we use this molecular orbital theory. For that, what you have to do is very simple method. Just remember a polygon. Yes, this is not maths class, but see, you have to remember this polygon. This is a simple trick, no? Very simple trick. So this diagram, this is actually molecular diagram in very simple manner. See, I'll be discussing that. See, now it looks like something like molecular orbital diagram, right? Initially it was just a mathematical polygon. Okay, see this. What exactly is this? Molecular diagram means atoms when they mix, orbitals are going to mix and they'll form, no, molecular orbitals. So that means, no, if you want a mixed juice, what is mixed juice? Suppose I want apple plus grapes juice, no? So what I'll do? I'll mix apple and green, like grapes also. The same thing, if O2 is combined, O2 molecule is formed. That means what? Oxygen atoms are combined. They also mix properly and they lose identity of atoms. When grape juice and apple juice both are mixed, no, you will get different taste because apple, no, that lost that sweetness, that sour taste will come from grapes also somewhat. Okay, so mixed taste you will get. Yes or no? Everybody will agree with this, right? The same thing, when atoms combined, they lose their identity. They'll form completely different set of orbitals here. They'll form molecular orbitals. See, this is applicable to 20 electrons. So each line here, no, each box, you can think like a box here. Everything is like a box. Okay, this is like a box. This is like a box. How many boxes we have? One box we place 2 electrons. So how many boxes we have? 6 into 2, 12. Now lower energy orbitals, no, there are like this. Quadrilateral, quadrilateral. As simple as that. No? See, this is one more orbital, one more, one more, one more. And see these boxes now. Count these boxes. Very simple trick. So this is energy order. Energy order. That means we have to fill the box from lower energy to higher energy. How many boxes we have? 4 plus 6, 10. So maximum electrons can be filled is 20. Exactly 20. So wherever the molecule is given, what you should do, you fill this in order, this energy order. Lowest energy should be filled first. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You should feel like this. So this is applicable for, very important, this is applicable for 20 electrons, as I said. But in 20 electrons also, this is applicable for nitrogen, till nitrogen. Means 14 electrons till nitrogen system, we should use this. And more than this, no, if you learn this, it is very simple. Other diagram. Okay. Now you write proper hexagon. This is proper hexagon. Okay. So this is the order. Okay. Each line here is like a box. Okay. Fine. So this is for what? From oxygen. Or from 16 electrons, you can use this order. Energy order is same way. Lower energy to higher energy. Got it? Exactly right. Okay. Now next questions also you can use this diagram. Please note it down. What I'm doing, I'm drawing this quadrilateral. Okay. Two quadrilaterals. Next one hexagon. Okay. Hexagon in different manner. Till 14 electron, this hexagon I'm drawing. But till 16 electron, this one. So now let us look at for oxygen. I'll tell you why it is paramagnetic now. You will get clarity. So oxygen means how many? 16 electrons, no? So first we should fill with lower energy orbital. 1 electron, 2. Count with me. Okay. 3, 4. Count. 5, 6. Please count. No. 7, 8. Next. 9, 10, 11, 12, 13, 14, 15, 16. So oxygen, what we got here, there are 2 unpaired electrons. They are not paired. Yes or no? This is not paired. This is not paired. And if there are 2, one up, one down, we call it as pair. Only one up means unpaired. Oxygen is unpaired. That means oxygen is paramagnetic. Yes or no? Paramagnetic. Got the point? So you got this trick, right? For 14 electrons, one diagram. For 16, from 16, another diagram. These two diagrams you should know. Right. Let us move on to the next question now. So this question is asking decreasing order of stability of O2, O2 minus, O2 plus, and O2 minus. O2, O2 minus, O2 plus, and O2 minus. So which is more stable or which is less stable? How do we decide the stability? Very, very simple way. Okay. Bonding electrons are more, or look at this again, I'll use the same term which I used, no? Bond order is greater, stability is greater. As simple as that. Because more attractions, more stabilities. But how do we find bond order, sir? How do we find bond order? So here, as these are molecules, we have a trick, no? We have a formula. 1 by 2 number of bonding electrons minus number of anti-bonding electrons. But how do we know in O2 how many bonding electrons? Look at this, no? For each diagram, and see this count from here. This is bonding, this is anti-bonding, this is B bonding, this is anti-bonding, and there are 6 orbitals, right? So now all these are bonding, all these are bonding, all these three are anti-bonding. Now tell me in oxygen, now you can clearly see in oxygen how many bonding electrons are there total? How many bonding electrons are there total? How many? 2. Count with me. 2 plus 2 4 plus 6 10. How many antibonding electrons are there? 2 plus 2, 4 plus 2, 6. So 10 bonding electrons, 6 anti-bonding electrons. So what I'll do is I'll substitute here. So with this, you can find out stability. 10 minus 6, that is 4. So 4 by 2, that is 2. So this way, we'll compare bond orders. More is the bond order, more is the stability. Getting the point, right? Okay. So I'll give you more questions here based on the same concept. Okay. Moving on to the next concept now. Yes, done. This one. From states of matter or gaseous state. Look at this question. Somewhat different concept. It is not chemical bonding. Now, gas properties. A mixture of N2 and Ar gases in a cylinder contains 7 gram N2, 8 gram argon. If total pressure is 27 bar, what is the partial pressure? Whenever there is a partial pressure term, so you should know what is Dalton's law. Dalton's law. It is applicable to mixture of gases which are not reacting. Applicable for what? Applicable for non-reacting gases. Okay, so now argon and nitrogen we already know, are they reacting? No, they don't react. Argon is in it, nitrogen is in it. So Dalton's law is very simple. Partial pressure of any gas, suppose I gas is there. So I'm not taking X because in mathematics, if we don't know any variable, we take X. But here X is mole fraction. We use it for mole fraction. So that is why I'm taking I. I can't take PQ also because P already used for pressure. So I am using ith gas. Okay. Pi is equal to mole fraction of that gas into total pressure. So this is Dalton's law. What is mole fraction? Mole fraction is equal to number of moles of that gas by total moles. So what you can do is here, nitrogen mass is given. So over there asking partial pressure of nitrogen, right? So number of moles of nitrogen is how much? Can you tell me? How many moles of nitrogen are there? 7 grams. Mass by molar mass. What is molar mass here? Nitrogen means N2 we should take. N2. So N2. 1 nitrogen 14. So N2. Do not confuse, 128. It is 7 by 28. 1 by 4. What is N argon 14? Now 40 it is given. 40. So 8 by 40. How much it is? Let us do this. 2 by 1 by 5. Exactly 1 by 5. One is 1 by 4. One is 1 by 5. Total moles we get 1 by 4 plus 1 by 5. Now number of moles of nitrogen we already know 1 by 4. So pressure of nitrogen is how much? Partial pressure of nitrogen. Mole fraction. Mole fraction, how do we do? 1 by 4 moles of nitrogen by 1 by 4 plus 1 by 5 into total pressure is how much? Total pressure is how much? 27 bar. So we get easily now. 27. Okay. So partial pressure of nitrogen is equal to, so 1 by 4. This is how much it is? 20. This is 9 by 20 into 27. So what is the value here? 4. Cancel this. Very simple maths we can do. So this will be how much? Partial pressure is 15 bar. Correct? Yes, exactly 15 bar. This is 5 into 3 it is coming. So that is 15. Okay, so this is about Dalton's law. From this question, what we have learned, Dalton's law. from gaseous state. Very, very important. Next question. See this. Okay, this question. Equal moles of hydrogen, oxygen gas are placed in a container with pinhole through which both can escape. A container is there. Okay. There's a small hole. But in this container, and remember students, when hydrogen is mentioned, don't take H. It is H2. When hydrogen gas in gaseous state, no, when hydrogen is mentioned, many students will confuse, no, sir, hydrogen, should I take H or should I go for a 1 gram mass? No, hydrogen means H2. Oxygen means what? It must be O2. Okay, getting the point right? Hydrogen means what? Always it is H2. Oxygen means O2. Okay, done. Now they are placed in a container. There is small hole. There is very small hole through which, no, this oxygen and hydrogen both are escaping. What fraction of oxygen escapes in the time required for 1/2 hydrogen to escape? Very interesting question. No? What fraction of oxygen escape in the same time required for 1/2 of hydrogen? 1/2 of hydrogen. So what is this? This is based on Graham's law. First, let us discuss this Graham's law. Okay. So rate of diffusion or effusion. No? You can say diffusion means what? Diffusion means spontaneous mixing of gases at constant temperature. Suppose in kitchen, if a mother is preparing chicken, uh, that smell will reach hall, right, bedroom, everywhere. So that is what? Diffusion. It is spontaneous mixing of gases. Or perfume smell, no, that when you press it, at that point it is effusion, high pressure to low pressure, the gas is coming out. But the kitchen smell, so what is that? That is diffusion. There is no high pressure in the kitchen, no, just the pressure is same, but still that smell is reaching to other rooms. That is diffusion. So whether it is diffusion or effusion, no? So that is inversely related to square root of density. Yes or no? Okay. Now this question can be solved easily. What I can write, if more is the moles, no, more gas can be escaped. Or this is inversely related to molar mass. If density is not given, we can use molar mass also. Higher mass, lower is the speed. Rate of diffusion basically speed. No? R1 by R2 is equal to root M2 by M1. They are inversely related to molar mass. And also equal to R1 by R2, N1 by N2, number of moles diffused per second. N1 by, what exactly you can write is N1, how many moles are diffused per second, by N2 by T2. Okay, so this way you can write formulas, but the question, see this, 1/2 of hydrogen to escape. What I'll do is, first gas I'm taking oxygen, 1 is oxygen, 2 is hydrogen. So R1 by R2 is how much? Let us first solve this. No, R1 by R2 is how much? First gas is oxygen. Oxygen molar mass 32, not 16. Hydrogen 2. So this will be R1 by R2 is equal to 1 by root 16, 1 by 4. Fine. Now R1 by R2 equal to N1 by N2 also. This fraction is given 1/2 of hydrogen. Now R1 by R2 is equal to N1 by N2. N1 by second gas is hydrogen, right? 1/2 of hydrogen to escape. 1 by 2. You're getting the point, right? So what I did is N1 by N2, because time is same. Time given is same for oxygen and hydrogen. So time is same. I cancelled out. N1 by N2. N2, we have taken hydrogen gas, so 1 by 2. But R1 by R2, we already know. How much is this? R1 by R2? 1 by 4. So that is equal to N1 by 1 by 2. So N1 is equal to how much? 1 by 2. So where is answer? Answer, yes. Answer is B. So 1 by 2 fraction will be escaped in the same time. Getting the point, no? 1 by 4 into 1 by 2. 1 by 4 into 1 by 2 is 1 by 8, right? One second. Sure. 1 by 4 into 1 by 2. So this is 1 by 8. Okay. Yes or no? Okay, don't do these silly mistakes. Okay, done. Chalo. Next question. Next question, see this. Temperature of a gas is raised from 27 degrees to 927 degrees Celsius. What about the root mean square speed of a gas? But what is this root mean square speed? RMS. We simply write this, no? Root mean square. Root, square root. Mean. Suppose N1 molecules are there with C1 velocity. Because gas molecules, there are many molecules moves randomly. They may have different velocities. Yes or no? All molecules will not move with same velocity. Suppose in a class, no, 80 students are there. All students cannot get first rank, right? Not possible. So even gas molecules also, they don't have same velocity. So they move with different velocities. So what we are taking as square root, mean N1 plus N2 C2 by N1 plus N2. But here square, N1 C1 square, N2 C2 square. Root mean square. What I did here, square root, mean, I have taken average, and square of velocities. So this is called RMS velocity, but RMS velocity simply we can calculate, no, by using 3RT by M. If I know a particular gas and the temperature, so we can find out RMS. Okay. So how do we do this now? Question. Temperatures are given. Okay, temperatures are given. Now 27 degrees Celsius to 927 degrees Celsius. Okay. Now root mean square of speed, no, it depends on temperature. You can clearly see this. So I can write like C1 by C2 is equal to square root of T1 by T2. Yes, I can write, right? Same gas. So M is same. Okay. Temperature dependence. So root T1 by T2, C1 by C2. But the most important thing many students forget is the temperature in Kelvin scale. That must be in Kelvin scale. Okay. Right. C1 by C2 is equal to root T1. This is 300 Kelvin. This is 1200 Kelvin. Okay. T1 is 300 by 1200. Yes or no? Now C1 by C2 is equal to 1 by 4 means 1 by 2 square root. So C2 is equal to 2C1. Yes or no? It is getting double. Okay. Shall we move on to the next question now? Okay. So now real gas. Because no person in the universe is perfect. We know this. Even the gases follow same. No gas is a perfect gas. No gas is ideal gas. All gases are real. Okay. So for real gases, we can't use PV is equal to nRT. This is for only ideal gases. But for real gas, we use this. For real gases, we use P plus AN square by V square. You cancel this. Okay. V minus NB is equal to nRT. So what they are saying is A and B are van der Waals constant. Yes. For every gas, A and B values changes. Okay. Now two sets of gases are given. One set is this, second set is this. So now see this question carefully. Gas is given in set 1 in increasing order of B. Increasing order of B means O2 less CO2 less H2 helium. And gas is given in set 2 in decreasing order of A. Decreasing order of A. Like this. This is A value. This is B value. Select the order from which are arranged below. Select the order, correct order from the following. Achha, set 1, increasing order of B. Achha, we should arrange. Okay. And set 2, we should arrange. Okay. Set 1, B value. Set 2, A value. So what we have to do for that? What is B? B significance, we'll be discussing that. No? B is more, size of molecule is more. As simple as that. Okay. As B value increases, size increases. B means, now let us compare B first. Oxygen, carbon dioxide, hydrogen, helium. We know helium is the smallest. Yes or no? Helium is the smallest. Helium is smallest. Because we know the sizes, no, from the periodic table, left to right, size decreases. So where is helium? Right side of the periodic table, no? Up, top, right side. So that is the smallest. Helium is smallest. So where is the option? Achha, only one option we have. Yes or no? Yes or no? Helium. Helium is smallest, right? Sir, hydrogen also we have, but this, no, H and helium. But H and helium, look at this, helium is smallest. Left to right, size decreases. So if you compare size, hydrogen is more, helium is less. So first option is matching. Helium, hydrogen, CO2, O2. Okay. Next, A. A for attractions. A is more, attractions are more. Okay. So where are the more attractions? More attractions are, I think this is, should be corrected, no? This is carbon dioxide, O2 and CO2. Okay. O2 compared to O2, definitely there is one more atom, carbon dioxide. Carbon dioxide should be more. Okay. And next, CH4, H2, O2. So what about the attractions? CH4, O2, H2. Where more attractions are present? What kind of attractions you have to see? Is there any dipole attraction? There is no dipole in any molecule. No, not possible. Just compare dispersion forces. Just compare dispersion forces. So which is matching now? Hydrogen has least attractions. So where is option? So this is option. So I think this should be the answer, but there is small correction. Helium is smallest, hydrogen is this. Okay. So this option is properly matching, fit into this. And there is small correction we should make. Helium, H2, O2, CO2, B. Okay. But attractions, hydrogen is least in size. No, there are very, very less attractions. Dispersion forces, we call it as. Okay. Fine. So with this, we have finished today's class. I hope everybody liked this class. Okay. If you like it, please share your feedback. Okay. And I already provided for the WhatsApp link also. You can join the group, WhatsApp group. Okay. Thank you very much. We'll meet in the next class. Okay. Today's class is awesome. Thank you. Thank you. You can access notes. No, what you can do is please click on the link and join the group. Thank you. Thank you. You will get. Can we get previous recorded lecture? Yes, please join. Please join. Okay. Please join the WhatsApp group. Wonderful class. Thank you. Thank you. Achha, I'll share the link again. Okay. I'll share the link again. 1 second, guys. 1 second. I'll share the link. Where is this link? Yes, that's the link. Okay. Thank you. Thank you. Thank you. Polygon trick. Did you like it? Okay, good. Thank you very much. Link is just provided. No, please see this. Just provided. In this chart only. No, in the chat box. No, please see this. Can we highlight this? I'm providing again. Okay, please join this group. Thank you. Okay. Okay, thank you everyone. Okay, happy Pongal, happy Makar Sankranti. Thank you. Myself Raju. Okay, my name is Raju. Okay, thank you everyone. Okay, bye.